Hello dear students. Question number 18. Current voltage characteristic graph. Okay. So we know that the first graph, which graph shows the for filament lamp. So the VI graph for the filament lamp is so A is not the for filament lamp because A is the ohmic conductor, because there are two types of conductor. One is ohmic and other one is non-ohmic. Ohmic conductor, the graph is a straight line, mean voltage is proportional to current or current is proportional to voltage, both are proportional. So the graph is a straight line. So A is the linear relationship between current and voltage. So this is ohmic conductor. This is for the metals. So A is not the for filament lamp. So B, the graph B is the for filament lamp, because we know that the filament, for the filament of light bulb, as the graph is non-ohmic, mean the graph is not a straight line. So this is a non-ohmic conductor, non-ohmic material. So basically, when the white is non-ohmic, because we know that when the current flows through the light bulb, as long as the current increases, so the resistance changes, R changes due to the temperature, increase in temperature, because we know that filament of light bulb temperature increases. So when the temperature increases, so that the resistance also increases, because we know that the temperature is proportional to resistance, or resistance is proportional to temperature. So if temperature increases, resistance also increases. So when the resistance increases, so it means the current going down. After that the current, so in this initially the graph will be a straight line. So as long as the temperature increases, changes, so that the graph tilt towards the slope decreases. We know that at this point the slope is different. At starting the slope will be there will be slope is the graph is a straight line, and after that you can see that the slope decreases at this point, and at this point the slope decreases. So if the slope decreases, so it means if the slope or gradient decreases, so it means the current also decreases. So current going down, so current decreases for the per voltage, so the current decreases. So V and does not proportional to I, V does not proportional to I at this moment. So that's why the graph is a decreases. Okay, so the current decreases. So that the B option is the for the filament of light bulb. C option is not the filament for the light bulb, it is for the diode. I think so it is for diode. For the diode we know that PN junction, so it is initially when the voltage is 0.7 volt, when the voltage goes after 0.7 or 0.3 volt for silicon, and for germanium 0.7 volt. After that the current start flowing, because the electrons need to cross basically the PN junction. Across the PN junction the voltage is 0.7 or 0.3, in case of silicon 0.3, in case of germanium 0.7. So after that the current increases, and then it goes up. So the current increases as long as you increase the voltage, so that the current increases. So I think this is a graph for the diode, semiconductor diode, not for the filament light bulb. So this option is also wrong. And D option is the filament of for a different material. Sometimes we can say that this is for the electrolyte. For the electrolyte, that this is a graph for electrolyte. Okay, so in the electrolyte, current voltage characteristics is represented by this diagram. So this is not for the filament of. So B option is the correct one. Okay, thank you. So B option is the for the filament of a lighted bulb.